All right, class, so we will continue our discussion on lines in this section 2.3. So again, it's still pretty much a review of algebra from other algebra classes before. And then we'll get into functions in our next section, our linear functions, which really linear functions is nothing but everything that we would have already discussed in the previous and this section. So let's concentrate some more on lines. So the slope of a line is really a big idea when it comes to lines. The slope of a line is simply a number that measures the steepness of a line. And how would we measure that? Well, here it is. Let me draw a line for you. So it doesn't matter how the line is moving. But the point is that if we want to see how fast this line is either increasing or decreasing, if you remember we talked in the section 1.4 about increasing versus decreasing graphs, and we measured average rates of change, and I even mentioned the word slope when we talked about that. So when we measure the slope of a line, all I have to do is pick 2 points. And by the way, I'm just going to say this first point has some kind of x1 and y1 coordinates, as in the x and the y of a first point. The second point has its own x and y coordinates. Has its own x and y coordinates. And so the slope, which by the way we always are going to label by m. Again, it's really because of the word mountain that has slopes. So anytime we're going to say find the slope, we're going to write m equals, right? M for slope. So the slope, m, what it simply measures is the change in the y's versus the change in the x's. In other words, it measures the rise in the line with respect to the run in the line. So if I go from this point to this point, how far up did I have to go versus how far to the right? Okay. And so again, we've already done this in section 1.4. So what we simply do is to figure out the rise, simply means to figure out the distance between the y coordinates. And to figure out the run simply means to figure out the distance between the x coordinate, or in other words, the change in the y's with respect to the change in the x's. So here is our slope formula. Okay, so let's immediately practice on it. Find the slope of the line that passes through -1, 4, and 5, 7. So again, what you have to do is take and subtract the y's over take and subtract the x's. Now be careful that x was already a -1. So just because I write -1 doesn't mean I subtracted -1. So it's going to end up with 2 negatives. 5 minus -1, you can test it with your calculator as well, is 6. And so, of course, we need to reduce the fraction. Okay. Here it is. The line passes through 5, -3, and 5, 9. So I'm going to subtract the y coordinates. So 9 minus -3. Over 5 minus 5, and this one's a funny one because it ends up with a 0 in the denominator. And what did we say about division by 0? we said division by 0 is not possible. So here is going to be a line that has no slope. Okay, do not leave this for me just like that. The slope 12 divided by 0 has to be finished, and you will have no answer for that. So put in your calculator and you'll see no answer comes out. So that's undefined. So I'll talk about it in a bit, what has to happen. What happened in this case. So here's another one I'm giving you, pretty funny. So I'm going to take 3 over 14 and subtract 3 over 5. And in the denominator, subtract the x's. And again, don't worry about a thing. Let your calculator figure it out. So what is 3 over 14 minus 3 over 5? Okay, negative 27 over 70. Okay, put in your calculator. What is negative 1/2 minus 1 over 7? That's negative 9 over 14. Okay, so now let's let your calculator do this operation. So what is negative 27 over 70 divided by, I'll put this one in a parentheses, and maybe I should have done the same thing here. Just 2, you can do insert. So insert here is above delete. So we want to insert minus. So I want negative 27 over 70 divided by a negative, I forgot what it said, 9 over 14. So type it in, press enter. Oh, look at that, 3/5 is the answer, boom. So the answer is 3/5. That's the slope, all done, okay. So I realized I should have put, I'm going to go all the way down here at the bottom where it's empty. I should have added some space to talk about what kind of slopes do lines have to have. Now, if a line is increasing, so as I go and look at it from left to right, the line is increasing, so it's going up, we will have a positive slope. If a line is decreasing, so it's going down, as I look at it from left to right, then the slope is definitely going to be negative. Now, though some lines don't go up, don't go down, they are going to be horizontal. So it's not going up, not going down. So it's horizontal. We just talked about it. Now, horizontal lines don't have positive slopes or negative slopes. They have slopes that are 0. So the rise, as you see in it, is 0. Okay, 0 is neither positive nor negative. And of course, we also have lines that happen to be vertical. Now, I kind of ran out of numbers. The numbers are either positive or negative, or 0 is neither positive or negative. In this case, there is no slope. So a vertical line has undefined slope. Why? Because the run is 0. This line is not at all going to the right. And division by 0 is undefined. So that's exactly the situation that we found ourselves here in the second example. The fact that we had an undefined slope, as you see, both x coordinates are the same. So if you were to actually plot these points, x is 5, y is negative 3, and x is 5, y is 9, you will see that you are on the same vertical line with it. Okay, so that's why the slope is undefined. Okay, so here it is. If I am given 2 points on a line, I can find the slope simply subtract the y's divided by subtract the x's. We'll get to practice this later on as we are adding on to the story. Now, any equation in two variables, I'm saying almost, and I'll tell you in a minute when not, can be solved for y. So if we start with that standard form of an equation in two variables that we talked about in the last section, we can rearrange it to get y by itself. So how would I get y by itself? Well, I'd have to minus this ax plus c, sorry. And then I'm going to have to divide by b, and we're going to do that a few times. And we're going to get y by itself. Same as we've solved all these other equations earlier in 2.1, right? Solve for a certain variable. Undo what's been done. So if something's added, we subtract. Something's multiplied, we divide. So we can get y by itself. This form, where y is by itself, in fact, it's a little bit unfortunate because the notations used here, the fact that we're using m for the coefficient of x is no mistake. The coefficient of x on the other side will always be the slope of the line. What's unfortunate about this notation is that we use this number b, which is, by the way, not the same b as in the previous equation. I wish whoever came up with this formula again could have just picked an n, something else. There's so many letters out there. But no, they picked b. And this b value stands in for the y-axis intercept, which we usually call the y-intercept. And we call this the slope-intercept form. And it's so important, we're going to use it so many times that I'm sure it will stick to your brain if it hasn't already, because you remember it from other algebra classes you might have done. Okay. Now, I already said here almost any linear equations can be solved for y. So some equations already have y by themselves, because remember, some equations are that of horizontal lines or that of vertical lines. So if I have an equation where the coefficient of y is 0, so therefore there's no y in this equation, this one cannot be solved for y. As you see, there's no y to begin with. So those are the vertical lines are the only ones that cannot get y by themselves. Okay, so let's practice on this concept for a little bit. I'm giving you equations, and they are in general form or the standard form, as we did in the last section, and I'm asking you to find the slope. And we don't need to find 2 points. We could do that, find 2 points on this line, but this is really not what this problem is about, and there's a much faster way. So to find the slope, all I have to do is take this equation and transform it into slope-intercept form. In other words, solve for y. So to get y by itself, I need to minus the 1/3 x over. So I'm minusing the 1/3 x from both sides of the equal. Then I'm going to divide by -2. So here it is, -2y divided by -2, that's just the y. take your calculators and let them divide -1/3 by -2. And what your calculator is going to say is something as simple as 1/6. And then 7 divided by -2 is -7/2. But what we're interested in is the slope of this line. So remember, I said if you get y by itself, the slope is simply the coefficient of x on the other side. So therefore, we know the slope of this line is going to equal to 1/6. Okay, let's try this again. This one's even easier because it didn't have that funny fraction and it doesn't even have minuses. So to get y by itself, I'm going to remove the 5x. Therefore, I subtract it. Okay. Then divide by 3. Because again, to undo a multiplication, we divide. So good thing we actually practice so much on actually solving equations for one variables, for linear equations. And here it is. Here is my slope. It's whatever x is multiplied to when we solve this equation for y. So when it says y equals, the coefficient of x on the other side is the slope. Okay. In fact, it's really easy when we think about the slope-intercept form of a line to graph that line. So let's play some more with the slope-intercept form. So here it is. Let me match it up for you. So when you think about this, the m is 1/4. The b is -5. Now, this b value was the y-axis intercept, which, as I said, we start by calling just the y-intercept. So that means I already know that my line's going to cross through the y-axis at -5. So I already have 1 point on this line. The slope is telling me how the line is moving. And the line has a rise of 1 and a run of 4. A rise of 1 and a run of 4. So in other words, this line keeps going 1 up to the right 4. Remember, the slope is rise over run. And that's it. So we actually didn't have to find any points. So if a linear equation in two variables has y by itself, so it's solved for y, that means it is in what we call the slope-intercept form. So we can immediately see what the intercept is and what the slope is, and use both those information to draw the line. So let's try this again. So start at the y-intercept. Now, many students make the mistake to go to the x-axis. No, this is the y-axis intercept. So go to the y-axis. The slope is the coefficient of x, so -2/3. So therefore, the line must go down 2 to the right 3. Down 2 to the right 3. Because again, -2 divided by -2/3 is the same thing as a -2 divided by a +3. So they're not both negatives, because if they were both negative, we'd get a positive answer, right? So one of them is only negative. By the way, you could think of it also as a +2 divided by -3. So from here I'd go 2 units up, but then the run is negative, so 3 left. So as you see, I end up in the same line. Okay. So we can use this slope-intercept form for great reasons. We can draw the line without actually having any points. We can look at the equation and immediately know what the slope is without, again, having to pick 2 points to subtract. And not only that, but we could also go backwards. And given certain information, such as maybe the graph of the line already, right? Here's the graph of a line. Or maybe we know the slope and a point, or the slope and the intercept, or 2 points. We can find the equation of the line. That's a big one. Many times we need to find the equation of the line. So the information's given to us, and we need to come back and come up with the equation of the line. So knowing the equation, we can find a lot of things, but also backwards, knowing things about the line, we now want to find the equation of the line. So we are using 2 formulas. Number 1, the slope-intercept formula, that's the y equals mx plus b formula to find the equation of a line. That's what we need to come up with, okay? There is a second formula called the point. So the point is some given point x1, y1. The slope is given to us. So if you know a point and you know the slope, you can find the equation of a line using this point-slope formula, which, by the way, is really nothing but the slope formula itself. If you take this equation on the side and you solve for m, you want to get m by itself, then m would be y minus y1 over x minus x1. So we knew that, right? The slope is the difference in y's over the difference in x's. So we got these 2 formulas to find the equation of a line. However, I personally will always just simply use the slope-intercept formula because we absolutely need to know this formula. It's so important for so many reasons, forwards and backwards. The point-slope formula, yes, if you were to go to higher math classes, calculus and so on, maybe you should learn it. It takes the same amount of steps to use either one. So I'm just going to stick with the slope-intercept formula because, again, we need to know it for so many other reasons. So here it is. How do I, still our job is to find the equation of a line. And the equation of a line will look like this. Y equals mx plus b. So what if I'm already actually given these 2 informations, that the slope is 3 and the y-axis intercept is 1. Well, then there you go. I have everything I need. So to find the equation of a line, I need to simply be able to replace the m, which this problem gave me, and replace this b that stands for the y-axis intercept, which the problem gave me. And here it is. This is an equation of a line. It now only has the 2 variables x and y. All right. Let's see, what if a point m, if the slope is given to us, but not the y-intercept. Instead, we are given a random point, -1, 5. No problem. So I don't have b. This y-axis intercept. Okay, well, we can find it. Why? here's the equation. I have a y, I have an m, I have an x, and this is how I can find b. So I'm substituting in this equation the given y, the given x, and the given m. And it's a really easy equation to now be solved for b. So b is 10. Now, remember, our job is not just to find b, our job is to be able to replace the m and the b so we can give the equation of the line. In this case, in the problem before, we were given both, the m and the b. All I had to do is replace it. This time we were given the m, but not the b, so we had to first find b so we can replace it. Okay? So both, either way, to find the equation of a line, I need to be able to know the m and the b. So here it is. As you see, if I am given 2 points, I don't know m and I don't know b. Well, let's find the m first. With 2 points, however, we already have talked about how to find the slope. So that's how I said we'll keep practicing on finding slopes, no problem, because we'll have more to do. So to find the slope formula says subtract the y's over subtract the x's. So in this case, I can reduce this a little bit. -5/3 is our slope. Okay. I also need the b. Okay. So I'm going to take either x or y. It doesn't really matter which one. So in place of y, I put 3. In place of m, I put -5/3. In place of x, I put -1 plus b. So what am I replacing? I'm replacing the y equals mx plus b formula. Okay, y equals mx plus b. So now take the 5/3 and subtract it. And you're going to get 4/3 with your calculators. So here's my equation. Y equals to mx plus b. All right. So same thing, I'm giving you 2 points. The first thing I'm going to need is the slope. So subtract the y's over subtract the x's. And this time you end up with 0 divided by -4. And 0 divided by -4 happens to be 0. Okay, pick an x and a y to plug into the y equals mx plus b formula. Well, 0 times 3 is 0, and 0 plus b is b, so b is 8. Okay, so let's write the equation down. Y equals to 0x plus 8, which is the same thing as y equals to 8. So as you see, we got one of those special lines where there is no x, and there's no x because its coefficient was 0, yes? So y equals to 8 is one horizontal line. And if you remember what we said, horizontal lines have a slope that equals to 0. So there you have it. Okay. So we're adding one more thing yet. Some lines are parallel to each other, and some lines are perpendicular to each other. Parallel lines simply means that they move exactly at the same rate. In other words, they will have the same slopes. They're tilted the same exact way. Perpendicular lines simply means that they form a 90-degree angle in between. So not that they're just intersecting. Lines can intersect at many different angles. The perpendicular lines have to intersect at 90-degree angles. What happens to their slopes, though, is that they have, I'm going to say opposite and reciprocal slopes. So in other words, if one line has a slope of 2/3, the other line has to have the opposite reciprocal slope. So that's what opposite reciprocal numbers look like. Okay. So let's practice on what we just did. We want to find the equation, again, of a line. So to find the equation of a line means to find something that looks like y equals mx plus b, right? So again, it's just the problems that we just did, but this time we're adding an extra layer to it. So either way, I need the slope, and then I'm going to need the b, right? I need the m and I need the b to find that. Okay. I am given a point, an x and a y, that I'm going to use just as we did before to find the b. But what information is going to give me the slope? Well, this information that's going to give me the slope is the fact that my line is parallel to this other one. So if they're parallel, that means they have to have the same slopes. So this is something else we practiced in this section. I'm going to take this equation and find its slope. So to find the slope, we need to solve for y. So I'm minusing 2x over, then divide by -5. So that's going to be a positive 2/5 x. Now this number here in front of x is the slope. So because my line is parallel, that means my line also has a slope of 2/5. Okay, because they have to have the same slope. So we're back already to the situation to where I am given the slope, and now I have a point, an x comma y, and I can use that to find the b. So y is 7, m is 2/5, x is 1, and there comes the b. So if you take 2/5 and minus it from 7, you're going to get 33/5, or 6 3/5. So therefore, the equation of the line I'm looking for is y equals mx plus b, where m is 2/5 and b is 33/5. Okay. So all we're doing is the same things. We're using, just adding on a little extra layer. So here's a couple more. Want to find the equation of a line. My line is perpendicular to this one. So because it's perpendicular to this other line, by the way, thank goodness, this line here already is in slope-intercept form, so I don't need to hunt for that slope. It's already there. It's simply the coefficient of x on the other side of y. So that slope is negative 2/3. The fact that my lines are perpendicular, it means that the line I'm looking for has to have the opposite reciprocal slope. So opposite means positive. Reciprocal means flip 2/3 to 3/2. Good. And now I need the b. And to find the b, I need to use the x and the y's given. So y equals to m x plus b. So 3/2 times -6 is going to put in your calculator, actually equal to -9. And then to finish solving for b, this is a simple linear equation. Add 9 to both sides, so b is 14. So therefore, the equation of the line I need is y equals m x plus b is 14. And there you have it. You have the m, you have the b, you have the equation of the line. Now the next question is a little bit tricky because it says to find the equation of a line perpendicular to x equals to 5. So when I'm looking at x equals to 5, I don't know what the slope is. It's not in y equals mx plus b format. So just think of it for a minute. What kind of a line has equation x equals to 5? Well, x equals to 5 has to be a vertical line. We talked about these. Okay. So what kind of a line is perpendicular to a vertical line? It has to be a horizontal line. So here, 1, let's say 9 is here. It's a little higher up, but again, I don't need the same units for the x and the y axes. So my line has to then be horizontal and pass through 1, 9. So horizontal lines always have as equation y equals to whatever y they all are on the line, and that y is a 9, right? So they're all at the height of 9. So this was a little bit tricky. We actually could not solve this with using the slope and the intercept and so on because we couldn't find the slope. For an x equals to 5, by the way, has no slope. It's a vertical line. But it kind of wants to review and go back over these two special kinds of lines that we have, which are the vertical and the horizontal lines. Okay. So our last job here is going to be to find the equation of a line if a graph is given. So I'm actually going to draw a graph for you. It's pretty straightforward. So what I want you to do is kind of hold on to 2 corner points that you might see. And I've bubbled them in here for you. And it's really easy to find the equation of a line. All I need to know is, can I read the y-intercept and can I read the slope? And the y-intercept is super easy. It's a 3. And for the slope, I have to count how this line is moving. So between these 2 points, as you see, the line went 1 up and 1, 2, 3, 4 to the right. So it's 1/4. Don't forget to write the x. So an equation of a line should have an x and a y. Unless, of course, their coefficients are 0, but none of them are 0. So y equals mx plus b. So read the m and read the b, and you're good to go. So let me draw another one for you. And again, you guys should try this first. So can you read the y-axis intercept? It kind of looks funny, but I meant it to go there through 4. So that's the y-intercept. And then the slope is, look at it. It goes down 2 to the right 1. Down 2, so the rise is -2. The run is 1. So that's the same thing as -2x plus 4, because -2 over 1 is just -2. Okay. And here I'm going back to piecewise defined functions. All of these are lines. So I'm going to remind you how in a piecewise defined function, we do read the rules, but it's important to say in between which x's are these rules valid. So the first piece we're going to read between, I'm going to delete it again. As you see, the first definition goes between an x of -3, which is included because we're bubbling in, and an x of -1, which is not included because it's open. And we'll read that definition. The next piece gives us the definition for x's between which two numbers. A -1, which is included because this point's bubbled in, and a +2, which is also included. And the last definition goes in between 2, not included, right? And 5, which is included. So now let's try and read the definitions of these lines. So it's all about reading lines. Now the easiest one is the last one. This one here is a horizontal line, y equals to -2. It's a horizontal function, right? The one in the middle is also easy. The y-intercept is -1, and as you look at the slope, it goes 1 up, 1 to the right, 1 up, 1 to the right. So that's 1x minus 1. Here, y equals mx plus b. I can see that the slope is 2 up, 1 to the right, but I don't necessarily see the y-intercept. I could see it, though, if I were to continue the line. I see eventually it would hit that at 3. So therefore, there's the y-axis intercept. Oops. So remember, in a piecewise defined function, we have different definitions. These are 3 different lines. And the definitions hold on different parts of the number of x's, right, of the number line for x. So we did a lot of work drawing lines, knowing the equation, reading an equation if we knew the line, finding equations of lines if we knew slope and points, even parallel perpendicular lines, or if we know the equations, finding the slopes. So we went forwards and backwards. For homework, you will have a lot of chances to practice these problems both ways, forwards and backwards. Knowing the equation, find a bunch of things. Backwards, knowing a bunch of things such as slope, points, graph, find the equation of the line.